The final mix of your game is dependent upon many things, and in many ways is a product of game design decisions. It's not just about the relative volume of sound objects, but it's also about their frequencies and position in space. In games, one of the additional challenges is that the number of these sound objects can be unpredictable, a particular issue since the possible number of simultaneous voices is often limited, depending on the specific console or PC we might be playing on. In this video, we're going to learn about the issues around voice counts, priorities, and concurrency. As we do so, we'll also be discovering a number of techniques that can help us with the overall mix of our games. On the opposite side of the river to the pig pen in the demonstration level, we get the increasing impression that we're entering dangerous territory. As the player walks in to this crow spawner blueprint, a number of crows appear and start to attack the player. Listen carefully to what happens to the audio as more and more crows are spawned into the level. I'm going to turn off the moving function of those crows so that we can hear the issue more clearly. What you might have noticed is that as more crows appear, the background wind sound starts to cut out. So why is this? If we look in our project settings and then go down to platform, and in this case Windows, we can see here that the max channels is set to 16. This is our channel count, or sometimes referred to as voice count. I've set it to 16 for demonstration purposes. The default is 32. Thinking about the current generation of consoles, the number of channels available for audio might be anything from 32 to 64 or even up to 100. For something like iOS devices, you might be looking at just 16 simultaneous voices, and possibly even lower for other devices. Even on a modern console, you'd be surprised how quickly your channels can run out. Think about how long reverb tails on footsteps might take up channels for a significant amount of time, for instance. With multiple characters in one area, it doesn't take long for the channel or voice limit to start getting hit. This limitation is, however, a good thing, since it requires us to start thinking about the overall mix and to start making some decisions. Back in the game, let's find that wind sound so that we can solo it. It's this one, Village Wind. So we'll get mouse control, solo that sound. You can clearly hear it cutting in and out. If we pull up the console command stat audio, we can see what's happening. If you look down the bottom, you can see the number of wave instances, and the max channels is set to 16. And underneath that, you can see audible wave instances dropped. So we're dropping 3 voices. They're being culled from the system. And one of those is the wind. By default, Unreal Engine will use the results of a volume multiplied by priority calculation to decide which sounds play. Each sound has a priority value between 0 and 100, with 100 being the highest priority. After concurrency decisions have been made, which we'll be looking at in a minute, all sounds are sorted in a list from high to low using this calculation, and then the top 32 or 64 or 100 sounds are kept active, whatever our max channel count is. So let's increase the priority for our wind sound, and we'll see if that improves the situation. Again, we can hear that wind getting cut out, and that's because of the priority multiplied by volume calculation. You need to take both priority and the volume of the sound into account. The wind sound might have a slightly higher priority, but it's quieter than a lot of the crow sounds. The priority multiplied by volume calculation assumes that as a general rule, quieter sounds are less important, but in this case it doesn't produce the desired outcome. For this situation, it's more noticeable, and hence more problematic, that the ambient wind cuts out, rather than if we lost one of the 30 or so crow sounds that are trying to play. If we wanted to ensure that quiet sounds don't cut out, we could set this priority to be really high. Or, the other option we have is to bypass volume scaling. so this is not taken into account when making these calculations. You could hear there that the wind sound remained present even when we moved away from it and it got quite quiet. If we want to make absolutely sure that a sound will always play, we can assign it to a sound class that has the appropriately named Always Play option enabled. You might use this for music or for the game over dialogue, something that's really going to sound bad if it's interrupted or doesn't play. Something else you might want to consider for some sounds is that we can actually vary their priority depending on their distance away from the player. In this case, it might be that the crows that are further away are less important than those closest to us. If we look in the crow sound cue, we can see that the priority is set to 1. But if we open its attenuation, here we have the ability to change the priority over distance. So in this case, we've got a min distance of 300 and a max distance of 2000. So at 2000 units away from the crow, the priority is going to be 0. When we're 300 units away from the crow, the priority is going to be 10. In the level blueprint, I've set up a shortcut key that's going to execute some console commands. This one's going to enable the audio debug commands, and this one's going to sort the sounds by priority. So if we enable that console command here, we can see that we've got the crows again, but now their priorities are varying according to their distance from me as the player. Like all these things, it depends very much on the specific setup and importance of different sounds in your game, but this can be useful for prioritizing those sound objects which are closest to the player. What we absolutely want to avoid is sounds cutting off or not playing at all because we've reached the maximum number of channels. So you'll want to put a priority system in place in order to create a hierarchy of importance, should this max channel count or max voice count be exceeded. Alongside this, we should put in some other systems that will make this less likely to happen in the first place. And this is where the concurrency system comes in. The priority settings are allowing us to fix a problem that we might have actually been already able to avoid. Do we really need 20 plus crow sounds to produce the effect we want? What we can do here in the sound cue is to control the maximum number of concurrent sounds that this cue is allowed to play in the first place. Now in this case, the sound cue isn't actually that busy. It only plays one sound at a time. The problem is when all the crows are playing their sounds at once. So rather than doing this on the sound cue itself, we want something that's going to control all of the crow sounds from all of the crows. So what we need to do is to create a concurrency set that all of the crows refer to. We'll put that in our audio concurrency folder and we'll call it crows. The max count is the maximum number of simultaneous channels or voices that this concurrency group is going to allow. For the crows, I'm going to set this to 4. The limit to owner option allows you to apply concurrency rules only to sounds belonging to a specific actor. But with our crows, we have lots of actors and we want to apply the rule across all of them. The default resolution rule is to stop sounds that are furthest away and then stop the oldest sounds. If we're stopping sounds, we also want to look at the voice stealing release time. This is the time taken to fade out sounds if the voice is evicted or culled due to another voice in the group starting. Stop quietist can be useful since it's the sound we're least likely to notice stopping, but in the case of the crows, there's so many of them that we won't notice the sounds on an individual basis. So I'm going to prevent new. Now we can see that there's never more than 4 crow sounds playing at once, despite there being many crow actors, because they're sharing the same concurrency group. Concurrency is evaluated first, and then the priority and volume evaluation kicks in if there are too many voices. So concurrency often solves many problems before they happen. For the crows, we prevented new sounds starting if the max count had been met, but on other occasions it might be critical that these new sounds are heard. For example, if they are in response to a player's action, like a weapon fire. In the demonstration level, you can fire off a magic bolt spell by pressing P. We want to clearly hear the sound of the spell in response to the player pressing the key, but these sounds are fairly long, and if they're rapidly re-triggered, then our max channel count can be quickly reached. We've just found a quiet area of the demonstration level to take a look at this. So there's a magic bolt spell, then there's an impact sound, and you can hear what happens if I re-trigger it too rapidly. So there you could hear the effect of sounds being culled or cut out because the max channel count has been hit. For these kind of re-triggered sounds, we can use the volume scaling system within the concurrency settings. This will scale the volume of older sounds when new ones play, making the older ones quieter. Using this system means that the new sound will always be heard at full volume, but that the old sounds will gradually get more quiet as new ones are introduced. So should they need to be culled, it will be less noticeable. This effectively gives us an automatic ducking system for sounds that belong to this particular concurrency set. In this instance, we've set the max count to 6. We've got a volume scale of 0.5. I'm going to just disconnect this layer of the sound so that we can see the effect of that volume scale more clearly. And I'm going to edit the blueprint for the collision sound and just temporarily switch that off as well. In my level blueprint, I've set up another console command here, audio debug sound waves 1, and that's going to give us a readout of the sound waves that are playing and the volume at which they're playing. So now we should be able to see the effects of that volume scale system. I'll execute those console commands, so now I'm seeing the sound waves, and I'm going to press my P button to trigger the magic bolt spell. So the original volume of the sound is 1.25. Now watch what happens as I rapidly re-trigger that. You can see that the volume of the older sounds exponentially drops off as the newer sounds come in. While we've got this example, we should also look at this re-trigger time option. Sometimes game systems can disrupt or break audio systems by sending them a series of very rapid triggers. This is really common when dealing with physics data, for example. The re-trigger time option in the concurrency settings allow us to block out these rapid re-triggers by creating a kind of cooldown timer. For example, I'm going to set this to a fairly extreme 0.5 seconds. I'm going to rapidly re-trigger the spell, but notice that the sound is not actually getting re-triggered any more frequently than half a second. This is another nice feature of the concurrency settings that again provides a solution to a typical problem. Another use for the concurrency settings is to restrict the voice count of a specific actor to 1. Just a bit further up from the crows we have this creature guarding the entrance to a cave. Let's have a quick listen. Looking at the creature's animation system, we have the breathing sound being triggered here. And here we have the bite sound. Now what we've done is we've assigned both of those sounds to the same concurrency set here. And this has a max voice count of 1. It's limited to owner, so it will apply to each instance of that creature. What this allows us to do is to restrict the creature to making one sound at a time. So let's play that in the level, and we're going to solo the prop sound class so we can hear it a bit more clearly. So the creature's breathing, and when we alert the creature, it's going to bark. Now what we don't want to happen is to hear the bark and the breathing sound at the same time, since that would be unnatural. By assigning both those sounds to the same concurrency set with a max count of 1, this is going to be handled automatically. This is a really nice system for handling monophonic actors. In other words, things like humans or creatures that can only make one vocal sound at once. In games, mixing is about more than mixing in the traditional sense. And here we've touched upon some additional concepts like prioritization and concurrency that can be considered.